Go. I am Mr. Bishop, the guy with the water bottle right there on the right. There's my Bitmoji. This is Chapter 3, Day 5. We're still talking about linear programming, and today we're going to do some actual applications involving a maximum. So we made it this far. We have all of the requisite knowledge. Some things I want to remind you of that we've talked about in some previous videos. For starters, we know how to graph and shade the constraints from a real-world scenario. Yes, we know how to do that now. Since we shade false in our method, the feasible set is going to be the open region when we're done. All right, we're going to have this weird-shaped open region. And remember, the definition of the feasible set is all the points that work or satisfy the system. Right? And we don't need to check all the points. We just need to check the corner points. Right? We just need to check the vertices, and that will tell us which one of those points will either maximize or minimize our objective function. In today's worksheet, we have 3 questions that are about scenarios that feature maximums. So I'm going to do the third and final question with you, and that'll leave you with the other 2 to do on your own. So it says, for number 34, about the shipping company, 2 kinds of crated cargo, A and B, are shipped in a container. Each crate of cargo A is 4 cubic feet in volume and weighs 2 pounds. That's probably going to be important. Whereas each crate of cargo B is 2 cubic feet in volume and weighs 4 pounds. The shipping company charges $7.50 per crate for cargo A and $10 per crate for cargo B. The container has a maximum load limit of 80 pounds, and the volume limit is 100 cubic feet apparently. How many crates of each cargo should be shipped in each container in order to satisfy the load limits and yield the greatest charges, or profit, however you want to think about that, right? Money coming in for the company. What's the maximum charge for a full container? Okay, and to help us out here, we've got some axes and a graph on the right. We've got this table here on the left. We should be able to fill this out then. Let's pull the numbers from the description of this problem here. So A, it said 4 cubic feet in volume, so that must be the volume for feet cubed. So A is 4, and then A also weighs 2 pounds. And for B, it's 2 cubic feet in volume and 4 pounds of weight. All right, and then it looks like we are trying to maximize the charge in this case, right? So that'll be our profit function for all intents and purposes here. And we charge $7.50 per crate A and $10 per crate B. And since this is a real-world example, we have limits in terms of our resources, which are volume and weight. So it says the container has a maximum load limit of 80 pounds, so be careful there. 80 pounds should go here, kind of out of order the way they're listed, and 100 cubic feet, so 100 would be for the volume or the feet cubed here. Okay, so when we go to write the inequalities for our constraints here, we're going to let X represent the number of crates of cargo A, and then Y, of course, will be the number of crates for cargo B. In other words, I can put X's here on the values for A and Y's on the values for B. So our constraint for the volume in cubic feet, right? We've got 4x plus 2y and then 100 there on the end. So our big decision is which inequality sign goes here. So since 100 is the maximum cubic volume, we can't go over that. We could certainly load the container less than that, but 100 is the maximum, so we've got to stay at or below 100, which means this sign is less than or equal to. All right, so that's our constraint for volume. And then for weight, we've got 2x plus 4y, and then 80 on the other side. Again, 80 pounds is the maximum here. We can't go over that. We could certainly have less than that in the container, so this sign again is less than or equal to. And let's not forget, x and y both have to be at least 0. We can't haul negative crates of cargo, so they've got to be 0 or more crates for each one. Okay, so let's get y by itself and look to graph these guys. I'm going to do the volume one in purple here. Let's see, subtract 4x on both sides. We get 2y is less than or equal to negative 4x plus 100. Divide everything in there by 2. And we're left with y is less than or equal to negative 2x plus 50. Perfect. Okay, that one is ready to graph. And then I'll do the weight in green here. So subtract 2x on both sides. We have 4y is less than or equal to negative 2x plus 80. Divide everything through by 4 to get y by itself on the other side there. And we are left with y is less than or equal to negative 1/2 x plus 20. There we go. Now that one's ready to graph. And I'm looking at this piece of graph paper that's provided. Notice it only has, I think, 10 or so tick marks on each axis. And right away I notice our y-intercepts are at 50 and 20. So if we count by ones, we're nowhere near where we need to be. That's no problem for us though. We'll just change the scale to count by a different number. And since it looks like there's about 10 tick marks and I have to go up to 50, I'll just count by 5s. So starting at 0 down here at the origin, we'll count by 5. So we've got 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and let's do the same thing here on the x-axis all the way down. 30, 40, 50, and this one actually goes out to one more. This one actually goes out to 60. Nice. So we count by 5s on both the x-axis and the y-axis. We're ready to graph these. So my purple line, I have a y-intercept of 50, so I'm going to put a purple dot up here at 50. And then my slope is negative 2, so I'm going to go down 2 over 1. Negative 2 over 1. There's my second dot. Let's continue that trend all the way across the first quadrant here. Down 2 over 1. There we go. And let's put our line down. Alright, put a line right through these points. There we go. And I'll shade that in just a second. Let's get the green line down first though. It says we have a y-intercept of 20, so I'm going to put a green dot right there at 20. And then a slope of negative 1 over 2. So let's go down 1 over 2. So right there. Down 1 over 2. Perfect. So I can see exactly the coordinates where these two lines cross. That's why I like to make the dots all the way across the first quadrant here. And before we shade anything, I want to take care of these two guys, x greater than or equal to 0, y greater than or equal to 0. Let's make sure those are done and highlighted as well. Those are the easy ones, right? So I'm going to do those in gold again. I'm going to make a line on the x-axis here, so that's y equals 0. And I'm going to shade everything below it. We are shading false as a reminder. So this one should be old news to you. Shade everything below it. Basically, it forces us to live in the first quadrant here. And then I'm going to make a vertical line at x equals 0. There it is. I'm going to shade everything to the left of that, right? Because that's where all the numbers that are less than 0R, and we are shading false. So once again, forcing us to live in the first quadrant here because this is a real world scenario. So you should be used to those gold ones by now. Okay, in terms of the purple and green lines, and again, we're shading false. I always want to make sure we're crystal clear on that. So purple and green, they both say less than or equal to. So if those were the roof of a house, right? If that was a roof of a house, or if that one was, when I think of less than the roof, I'd shade below. However, in this case, we are shading false. So the false of that would be shade above. So I'm going to go ahead and shade above the purple line to start. Nice and quick there. There we go. Let the iPad do the work. And there you have it, ladies and gentlemen. There is our feasible set, that open region in the center there. I'll highlight it in pink, right? This weird quadrilateral shape. That is our feasible set, that nice open area. So we're done with the graphing and shading. We need to figure out what's the maximum charge for this scenario and how many crates of each type, A or B, results in the maximum charge. So we know it's one of these corner points that will give us our maximum value. We just have to plug in each point to our objective function. So I usually make these tables vertically. I'm going to go ahead and make it horizontally in this case. So I need to know about the corner points and, of course, our objective function, which was $7.50 for each x and $10 for each y. Well, I've got those switched right now, don't I? Let's fix that. $7.50 for each x and $10 for each y. That's our objective function. That's going to give us the amount from the charges. And we mark that in our table up here in the last row. So let's identify the corner points here. I'm going to put a pink dot on each one of these guys. There we go. We got 0, 0, 0, 20. Looks like 20, 10, and 25, 0. So let's list out those. So 0, 0, 0, 20, 20, 10, and 25, 0. The maximum has to be at one of those points. That's the fundamental theorem of linear programming. We only have to check the corner points. Well, without doing too much math, you plug in 0 and 0 for x and y, right? That's not going to give you a whole lot of profit or a whole lot of charge in this case. So plug in 0 for x and a 0 for y, and you're left with $0.00 from that function. So it's not going to be the origin. What about 0.20? Plug in a 0 for x, plug in 20 for the y, and you should get a nice, easy $200. Is that the maximum, though? We still have 2 points to go. So how about 20, 10? Plug in 20 for x and 10 for the y, and we get a value of $225, which is our new leader. Okay, and then our last point to check there, plug in 25 for the x and 0 for the y. Unfortunately, that's not going to be our winner. That's $187.50 for that value. So our winner for the max charge on this container, $225 when we have 20 crates of cargo A and 10 crates of cargo B. Let's go ahead and answer that over here. 20 crates of cargo A and 10 crates of cargo B gives us our maximum charge of $225. All right, there you have it. Now we're using our linear programming skills to answer these real-world scenarios. We're graphing and shading, checking those corner points, and seeing which one gives us a maximum in our objective function. That's all for this video. Thanks for watching.